Good afternoon, everybody. Welcome and thank you for joining us. This is a panel on crowdfunding and robotics and automation, and delighted to have you with us today. My name is Mike Bell. I'm the CEO of Miso Robotics. Miso Robotics provides AI-powered robots that take over cooking and food preparation tasks for restaurants. We've been in business for about 6 years. We're founded very close to here in Pasadena, California. Have about 120 people and are just now entering the phase of actually commercializing the robots we've been developing for 5 or 6 years. They're just now, as we speak, kind of rolling off the production lines and being installed in some of the nation's leading restaurant brands. And I'm happy to tell you more about this as the panel continues. But let's first have a brief introduction from each one of our panel members today. Mitch, can we start with you?
I'm Mitch Tolson. I'm with Ally Robotics, and we started in December of last year. We are creating a smart robotic arm designed for anyone to be able to come in, program, and train this to perform tasks that they want to be able to complete. We're both a hardware company and a software company, and we have a couple initial customers of ours, one of them being Miso Robotics, and then other applications range from helping roofers with laying up their 3-tab tile to even in manufacturing scenarios where you're completing the silvering of Christmas ornaments. And right now, we are actively crowdfunding on Republic, republic.com/ally.
Darian, CEO of Bobacino. We are an automated teapot where we build in, either you could think of it as a restaurant shrunk down or a next generation vending machine where we're leveraging the power of automation and robotics to serve bubble tea. We're about 2 years in. We're going to launch our first public field unit early next year, and super excited to be here. John?
Hi, I'm John Valet, the CEO of Graze. We're building an electric autonomous lawnmower with a 60-inch mow deck for mowing large areas, golf courses, athletic fields, city parks, really any place that you need a 60-inch mower. It's been my pleasure to be working with these guys. We've done crowdfunding and raised $15 million from 17,000 investors, and we've just launched a Series B just this week to raise some more.
Excellent. Glad to have you all. Looking forward to our conversation. So, robotics and automation and crowdfunding. Like, what's the connection, and what's relevant here? A couple things I'll point out. One, that robotics and automation are uniquely appealing to crowdfunding, and crowdfunding itself has been a really critical and foundational part of each one of the companies up here today in terms of a part of our success and a part of our overall capitalization and growth strategy. So it's key to us. Second of all, when you look at crowdfunding at its heart, it's a democratization of the capital markets, of the opportunity to invest in early stage tech companies. Similarly, robotics has a democratization of sorts underway. There's such a sea change going on in the labor markets and how labor and work itself is being distributed. It's absolutely being redistributed and reallocated from man to machine in many industries. And so these fundamental shifts that are underway both in society and the workforce, as well as how individuals can invest their private money into companies like these today, make it a really, it should be a very topical conversation, and I think it's a very pertinent one. So looking forward to get started. Before we get started, real quick, round robin, what has crowdfunding done for your company in terms of just where are you at with it? I'll go first. Miso Robotics has raised almost $90 million across 3 rounds of crowdfunding. We did a Series C, a Series D, and a Series E. And the company has a valuation now in excess of $500 million and is actually active right now with their Series E campaign.
Ally Robotics, we're an active fund right now, as I mentioned, republic.com/ally, and so far today we've raised 4.7 million through Crowdfund, and we are actively raising today. Yeah.
Bobachino's raised just under $4 million across 2 rounds, and we're looking to raise again probably sometime early next year.
Yeah, so through our A+ round, like I said, we raised $15 million, which is critical to the product development to get us to where we are today, and then ultimately where we need to go to get to contract manufacturing and go to scale to bring our product out to our customers. The other thing crowdfunding has done is because of the advertising and everything we do, be it on Facebook, on LinkedIn, we've really connected with people all over the world, and we're finding there's a huge labor shortage everywhere, be it Japan, South Africa, Europe, Australia. So we're also really branding our market and going nationally, internationally.
Excellent.
I want to add one thing for Ally specifically as answering kind of the question of why crowdfund. And there's a couple different reasons. One of them is we're looking at automating these scenarios that are for just anyone, anywhere. And through that, it's intrinsically natural to go to the crowd to get their interest. We've seen that over the few thousand of the investors that we've captured so far, many of them have called me up and said, hey, I got this scenario, can you help me out? So it's not only helped just in directly raising capital, but also igniting a whole customer pipeline, as well as I look at some startups that when they go to IPO, they haven't done any brand recognition, awareness, and so this actually is intrinsic to just helping tune the strategy, listening to that audience, and also advocating of what you're doing, why that's relevant, and how you're going to help other people and entities.
Yeah, excellent, excellent. So when one looks out at society today, there's kind of a broadly accepted feeling that we're at a entering the golden era of robotics. There's a clear tipping point happening where robotics are rapidly becoming mainstream. When you look back 10 or 20 years, robotics were beginning in perhaps manufacturing and then certainly in warehousing logistics. There have been robotics advancements in the field of surgery. Drones and self-driving vehicles are robots of sorts, for sure. But you're starting to see, with Optimus from Tesla and other examples of robots quickly becoming mainstream, and it's not such a unique, rare, oddity anymore. It's we as a society are just becoming more and more accustomed to seeing them kind of all over the place. In the restaurant industry in particular, there has been before the pandemic, there was a labor gap. The restaurant industry called it a gap. And what the gap means is the difference between the available positions that they were looking to fill and the supply of humans who wanted those jobs. It was a gap that was kind of persistent, and there was roughly, call it 800,000 open positions before the pandemic. Most people aren't aware of this. Most people think that the labor situation that's evolved in society was brought about by the pandemic, when in fact it was exacerbated by the pandemic, predated the pandemic, and the pandemic just accelerated societal changes and individual changes with workers that had them suddenly look at the scenario of like, I don't want to return to this job. And so today, the restaurant industry has a labor gap of close to 1.6 million people. And there is no real scenario, and that affects all of us. When we go and order food from a fast food or any kind of restaurant, there's oftentimes we experience this shortage in labor by either having bad service or just simply a restaurant that can't keep up. There's just not enough humans to go around. There's no real scenario where we wake up one day and 1.6 million people suddenly happily return to this workforce in this particular industry and are happily retained and happily kind of engaged. And there's no real scenario where that evolves. So all eyes are on automation. So in the restaurant industry and in other industries, all eyes are on companies like the ones on the stage before you today to hurry the heck up and help solve this problem that's kind of vexing the industry. And so before we kind of dive into the really specific questions about how these changes are affecting your industries, Mitch has a very unique perspective. He has been not on the sidelines, but actually on the playing field with robotics and automation for a long time. And so I think it might be helpful to have just a few minutes of Mitch who give us kind of the background in a Cliff Notes version, if you would, in terms of the technology and how we got here.
Sure, thanks. So I look at, actually I'd start way back. I look at people have, for a very long time, have created tools to help them do things more efficiently and create new capabilities and features. And if we fast forward to like the early 1800s, this was kind of amalgamated into the looming machines, where we could increase throughput of textile manufacturing. And in the early 1900s, this kind of automation moved into the scenario of where we had glass bottles and they were delivered milk, right? And it's about cleaning those, then refilling them and capping them. And so that's kind of like the beginning of this, where we have doing one thing very repeatable and at high volume. And in the automotive industry over the 1900, that's where a lot of this tech started to be applied and developed. And it was 1959, there is this robot called Unimate that General Motors used. The challenge was people were, you had these 75-pound parts that were hot die-cast parts, and they built this robot to be able to handle and manipulate this part. And that was kind of this beginning of, how do we take not just conveyance systems, but really these kind of abstract mechanical systems to help automate workflows. And then even further, in '69, there's this robot called the Stanford bot, the Stanford arm, that was the first electric-driven 6 degree of freedom, degree being, you can imagine, a joint, robotic arm that was kind of making something that was useful, adaptable to changing scenarios. And then, so that's kind of in the manipulator space, but then from a mobile space in '72, there's this robot called Shaky. And it was really interesting. They used a set of Tiki cameras, and you could give it a goal, and it would drive to or push objects around this space. And that's kind of like the start of the autonomous mobile robots that we see today. Fast forward several years with the advancements in silicon and the advancements in just consumer electronics, we started to see robots such as the Roomba in 2002, which is going around sweeping inside of houses. And then on the logistics space, again, where you have this scenario of high volume, how do you move parcels from one space to the other? There's a company, Kiva, that was ultimately purchased by Amazon that solved kind of that movement of materials at scale. And so from that point, then you had things like certainly Big Dog by Bison Dynamics, and you have these other type of structures. But really what we're seeing now is that we have now these mechanical systems, and we have also advancements in software from RL and behavior cloning and things that we're now bringing together in scenarios that open up this opportunity for automation. So things like going to the logistics, these mobile robots started with following guided wires, and now it's moving into, well, a person from a labor standpoint. A lot of these shipping companies, they have challenges of finding people to drive these vehicles, that path is 15 minutes from point A to point B, and they do that day in and day out. Well, can we build a autonomous mobile robot to solve this problem? And that's where we get into things like fleet management and localization and other sets of software technologies to help us automate these kind of abstract scenarios that are not on the manufacturing line doing things at high volume and in a repeated fashion. And this is kind of what opens up scenarios like Graze and for Bobocino, where it's now you have Graze is kind of that same thing of you have a lawn, and how do you build that path plan, and how do you take that hardware software together into a product that solves this end customer need, helping to mitigate this growing labor shortage.
Okay, and in going through that background, you described a lot of things that existed or pre-existed a long time ago, or how do you describe the difference between automation and robotics? Because a lot of people look at what I think of as automation and go, hey, that's been around for a long time. What's the big deal?
There's some jokes that say, a robot isn't useful until it becomes, an automated system. But I really look at robotics as being able to, automation is doing the high volume things with low mix, low variation of whatever that thing is. And robotics is really going towards that. Well, the world is messy and it's dirty and it's abstract. And so how do we solve these kind of changing dynamics? Somebody walked in front of my mower. What do I do? How do I perform this mission in a very safe and reliable and repeatable way?
And talk about real quick, before we move on, what are the big chunks of technology that are accessible now that weren't accessible 10 years ago?
Certainly, if you look at from a hardware standpoint, actuators and motor technology has advanced. There's also, when you look at mobile robots, the battery technology has also advanced significantly. And then also from a software standpoint, there's things like robotics operating system. That has really helped the ecosystem of developers converge into, here's a framework on how we develop different, I'll call them packages or modules, in a repeatable way that then you're plugging and playing. Somebody built an optimal way to scan your environment. Somebody built an optimal path planner. And bringing that all into a core set of really a communication framework that now developers and product companies can leverage and say, well, now we don't have to start from zero. We can leverage this open source tech and really get to that product value faster. Got
it. So for Miso, computer vision and AI is a big part of what's kind of suddenly enables a machine that does something to be distinctly different from a machine that does something intelligently, that's self-aware, that knows where it is in space. Okay. John, sticking on the theme of technology, has there been any significant pieces of technology that have just suddenly or dramatically enabled the function of your product?
You mean in the landscape industry that has really taken hold?
Yeah.
No, there's, we've been using the same old mowers for decades. About 20 years ago, a zero-turn mower came out, which meant you could, make a real good U-turn, but it's all manually operated. You're either standing on it, sitting on it, or pushing it, and it's just very labor-intensive, and that's why we're looking to make it automated and do, like you say, the same thing, but probably better, because we'll be able to maintain a 4-inch overlap, we'll get to the perimeters, get around the trees, and what we'll do is we'll upskill those people that are otherwise sitting on a mower all day, and we'll train them allow them to be trained to do irrigation repair, integrated pest management, pruning of trees. So by upskilling them, they'll be able to earn more money, and it's in huge demand with all landscape contractors.
Right. And I think of a lawnmower, maybe 10 or 15 years ago, technology that could keep a precise line just to actually understand where it was in proximity, that technology was a lot more expensive or just wasn't available.
That's right. And also, even 4 years ago, the electric mowers that were out there could only run for about 3 hours.
Right.
Well, landscape contractors need it to run 6, 7, 8 hours a day.
Yeah.
Otherwise, they're going to be towing around a big piece of equipment that they can't use.
Yeah.
So it wasn't until about 3 years ago with the battery power to get it up 7, 8 hours.
Yeah.
So
okay.
that's where we've been helped by the EV market, is through LiDAR, the GPS, the battery technology. It's all coming together, which is making what we're doing much more affordable than it was even 5, 10 years ago.
Got it. Darian, what are the big pieces of technology that enable your solution?
There is probably less technology than anybody else here on this deck, but there's still, I think really one of the big key drivers has been just the reduction in cost across the board. Your motors are cheaper, your drives are cheaper, your programming is cheaper with stuff like Ally, where you can literally just tell it what to do or show it what to do and it does it. Yeah. All that has created a certain accessibility to the robotics built into it, to be able to reduce the cost and be able to speed up our product development timelines, to be able to get something like this out into market faster and make it much more accessible. Whereas, even 5, 10 years ago, a robotic arm like the one we use, your starting point is $20,000, which is just untenable for these things. And so you've seen this kind of intersection of automation costs and robotics costs come way down with the expansion of that market, and your labor costs going way up. And as you mentioned, not having access to the same labor, people just not wanting to do those jobs anymore because they're hard and they don't pay well, and just now they're starting to slowly but surely catch up to what they should be getting paid. Right. They still don't want to do that, right? And so with that intersection of increased labor costs and decreased automation costs, we're able to leverage technology that we use at Bobicino.
Excellent. Okay.
Certainly also the cost of sensors has reduced significantly.
Right.
Like LiDARs, companies like Velodyne and stuff, they've really tried to drive down that cost. There's also this, as compute has advanced, evolved, we have now this high performance compute clusters that you can now simulate the task a robot's gonna do at scale. So instead of me just manually pushing a mower and that's my one data set, I can now recreate that same and replicate it 10,000 times in one simulation environment, train an RL model, and then now I've optimized that a robust policy to then follow that path. So there's other advancements in other industries that have really helped robotics.
Right, and the pace seems to be accelerating.
That's right.
Okay, let's pull back and let's shift gears a little bit. There is rarely a public opportunity when a robotics executive is talking about robotics online or at live, when you don't get the question, sometimes nicely and sometimes in a heckling context, you guys are killing labor. What you're doing is taking away jobs from human beings. So let's run straight at that. John, you want to go first? How dare you do that?
Yeah, like I say, I mean, some people say, well, you're taking jobs away. It's like, no, there's nobody there to fill the jobs. And in the United States, there's a HB2 visa program to bring in seasonal workers from Central America, the Caribbean nations, and it's basically a lottery system for landscapers. And they put in at the beginning of the year, beginning of the season, and if they get an A or a B, they'll get their workers. If they get a C or a D, they're going to struggle to even stay in business. So it's not about taking jobs away from people, it's allowing a company to do more with less labor and taking that labor and upskilling them. So I think it's just a win-win for everybody. It's a win for the laborers that are otherwise sitting on a mower all day. It's a win for that contractor that wants to grow their business. And it's a win for the customers because they're ultimately going to be able to get better service at a lower price.
Got it. Okay. Anything to add?
Yeah, I mean, in terms of our model, the way that we're developing the machines, two things, I'll touch back on kind of like the lack of labor available to do this type of thing, but really the way that automation has leveraged this, our application in Bovicino, is that we're also able to locate these things where restaurants normally couldn't be. So normally when you'd open a restaurant, you need a brick and mortar location, you got to get all the permits for it, you got to rip them all out, you got to do the reno, you're costing hundreds of thousands of dollars to get this thing set up, and then you have to find the staff to run the store. With these, we are really marketing to existing shop owners to be able to deploy these things in places where their stores couldn't exist already, and now you can create this spoke and hub model that they're able to reach more customers without having to create new brick and mortar stores and expand their business and their impact. But going back to kind of the central thing of taking jobs, there was a labor market study in 2021, and the real short Cliff's Notes is of interviewing all the people searching for jobs. What it came down to is 1/3 of the people that were actively looking for jobs in 2021 not only had no interest of going into like the service hospitality sector, but there was literally nothing you could do to change their mind. Didn't matter if you were giving them free food, didn't matter whether you're paying them crazy amounts of money, didn't matter whether you're giving them benefits, like could not convince 1/3 of the labor market to get into like the food hospitality market for any reason at all. And so like the whole argument of like this is taking jobs is like, no, like you couldn't offer people enough money to do this.
Yeah.
Try getting them in the landscape market.
Yeah. Well, in that regard, you're kind of saving jobs because you're allowing the companies and the entities to survive and to be actually viable in and of itself.
Not just saving, but it's also helping them upskill and do more rewarding jobs. You can look at it in that if you look at manufacturing industry alone, over the next 10 years, as governmental incentives and CEOs reshore manufacturing back to the US, there's going to be a 3.5 million job deficit. And they believe that with all their existing programs that they could find 1.5 million people to fill that gap, but there's still this 2 million job gap. And so this is where, from an Ally Robotics standpoint, I look at it as if we can make our technology so simple that anyone can program and train these robots, those 1.5 million people can train robots how to do the jobs of the other 2 million that are going unfilled today.
Got it.
Well, and
Okay.
sorry, just to touch on one more thing, Mike, thinking about Miso is that like your guys' core application is doing something that is repeatable and back of house and the miserable, like the dirty, dangerous, and
Dangerous.
jobs that people don't want to be doing in the first place. And then it, like what you're talking about earlier about how the staff is more disgruntled because they're getting run to the ground and you don't have the support to be able to do these things. By having an application like Miso that's now doing the back of house stuff, that frees up that staff to do the things that humans do best, which is be humans to other humans. You're doing the customer service, you're treating people with respect, you're caring about what they're doing, and you can leave a robot in the back that's just frying burgers all day to do the rest of that support.
Right. We get Miso gets called in to the nation's leading restaurant brands because of a labor problem, because they don't have enough staff to open certain locations, or they certainly rarely can operate at peak efficiency. So we get called in to solve one problem, which is to kind of fill this gap. But when we do so, when we install a robotic fry station, Flippy is our most well-known product. Something interesting happens when we install Flippy. What happens is the human being or human beings that were at that fry station get placed elsewhere in the restaurant, either at the drive-thru or at the drink station or the delivery station. There just simply isn't enough body to send them home. And so by allocating that labor to the very next bottleneck in the operation, restaurants actually, their capacity goes up. They can actually produce more food, which means they can sell more food, which means, believe it or not, they actually increase sales. Now that is a way more compelling benefit for our customers. It's not one they expect. It's one we tell them about and tell them that this is kind of what we generally see. But it certainly transcends the overall conversation about an operating expense gap to a far higher value, which is driving revenue. So if we're doing all these great things and we're not taking jobs, what the heck is taking so long, right? Like we get that all the time. So I'll ask the question about the individual companies in a second. But first, let's talk about where each of you are at in your respective industries in terms of in your pace of adoption, in your industry's pace of adoption. You can answer it in terms of baseball innings or what time on the clock, but like how early are we in each of us in our industries? Darren, you want to start?
Sure. Yeah, we're pretty early. We're looking to launch our first field unit early next year. It's been, what's taking so long is honestly, as much as we talk about how costs have gone down and how we've been able to leverage off of, existing software stacks and decrease parts, there's still a lot of work to be done. By integrating the parts in the right way, getting through the right certifications, making sure that what we're developing is not only safe, but a really high quality product, so that ultimately we can deliver something that people are going to love. I mean, that's been one of the other advantages of equity crowdfunding, is being able to put our machines, our business model, our approaches out in front of the crowd and get feedback before we can actually get a product out in the market. And so what we've been really doing is refining our product to make sure that we are getting something out that's going to be worthwhile and that people are really going to love. And we really be able to get those first proof points before even getting a market out in front of people in real life. John?
Yeah, very early. Interestingly, 2018, when I was still running a landscape maintenance company, I went into my local lawnmower shop, and there was a sign that said, "Ask me about robotic mowers," which I did. We went out to the Google campus, and it was a Roomba-type mower that was going in all these random different patterns and required guide wires to put in, and it just kind of looked like a bad haircut because it hit some areas, it missed some areas. But right then and there, I said, man, if somebody could come up with a mower that you don't need to put the guide wires in the ground, which is labor intensive and it's easily broken, can go back and forth in parallel lines like you're used to seeing, and be big enough for commercial use, they would have something. Well, about a month later, I was put in touch with the general manager of Vibu, who has a robotics lab, and about a year after I met with him and talked to him, I became the CEO of Graze. And so what's helped us is because with Gavin Newsom saying in January 1st, 2024, you can no longer sell gas-powered mowers, we're all electric, and there's not that many electric mowers out there. I was out at the Landscape Expo last month in Louisville, Kentucky, and all the big boys, John Deere, Toro, Exmark, Now they're all introducing electric mowers, and the natural leap is going to autonomous mowers. So whereas we're still very early, everybody in the industry can see that what we're building and what's happening in the industry, we're going to be there. And probably wholeheartedly within 5 years, you're going to be hard fought to find a manually operated gas-powered mower, because what California's doing is ultimately going to transfer to the rest of the states.
When prospective customers see your solution, do they kind of go crazy and say, geez, where have you been all my life? Like, is it receiving that kind of adoption?
Oh, absolutely. I mean, landscapers, contractors, they're looking for equipment, they're looking for ways to get the job done faster. And so if we can show them a robotic mower that now you don't have to have a person sitting on, and it can be more precise. We've got an actuated deck that you can adjust the height up and down rather than manually tweaking it, which will help us for a future generation. We'll be able to detect how tall is the grass that we're going to mow, and it can adjust it accordingly. People love it. In fact, we showed it to a large distributor at a demo, and all we had to do was remote control it off and on to the trailer. Once we got it to the mow spot, it would just do its thing. And the distributor said, man, I can see that's the future, but we're not going to be doing as many repairs on manual mowers anymore, because most of the damage happens getting it on and off the trailer. And being electric, there's not a lot of moving parts, so there's virtually no maintenance other than swapping out the blades and sharpening the blades. So yeah, everybody we've talked to, potential customers, they're like, when can we get it? They're ready.
I imagine. Mitch, let me set the stage for your answer. So, because Mitch is a very humble guy, Ally Robotics may be one of the fastest moving robotics companies I've seen in terms of just their pace. Would you describe these guys, not only where you're at, but how recently you started and where you're at?
Yeah, sure. So first, before I answer that, I look at from an adoption standpoint, we're building a smart robotic arm. And so there's been a lot of advancements within factory automation, 30, 40 years of these improvements. But these innovations don't necessarily translate well to what we're looking at solving is everyday automation. It's the person trying to cook French fries, or maybe mounting an arm to a lawnmower that does the edging.
Right.
These other type of scenarios that we people don't necessarily want to do. And it even goes back to the answer of the readiness. It's both my parents, they had companies when I was growing up. And I started my first small little restaurant, hot dog stand, popping a hot dog for $1. And when I was 11, and I made $10,000. And I remember very specifically, I had lines lined up, and I couldn't cook hot dogs fast enough. And it's like, man, if I was 11 and I had a robotic arm that I could just show it what to do, I could get more throughput of my hot dogs, and those people would have been served, and I would have had more revenue. And so I look at and then when we did this crowdfund, I had investors that turned customers. They're like, I can't wait until you're ready. When can you be ready? And it's this energy of, like Mike was kind of teeing up, is we started in December of last year. We've built several prototypes, over 8 prototypes now. We'll be in full manufacturing by middle of next year. And this is where I have a group of, these customers that are, please get me this unit. And not only that, but can I be a part of your pilot program? And this whole connection started from the crowdfund and just awareness that we're doing these things.
So Ally's product is a breakthrough robotic arm. And it may be surprising to hear, but robotics arm themselves have quickly become legacy and kind of old tech. Like they're all kind of, cast aluminum and kind of the same actuators, super expensive, heavy, very slow to manufacture. So Mitch's company is developing a robotic arm that you can teach it visually, like what it's meant to do. Mitch, other than frying French fries, where might some of the people listening to us today, where they might see one of your arms next, other than frying fries?
Certainly there's manufacturing scenarios. I look at right now, we have 10 customers that we're working with from I wanted to start the company deeply partnering with customers, understanding those key requirements and solving for that, and not not taking on extra scope or just creating cool tech for tech's sake, right? It's in working with Miso, they have this industrial robotic arms have this large control box. How do we get rid of that thing? They're very heavy, so installation is challenging. It takes several people to install these arms. How do I make this arm that it's one person, installable? It's things like in not just quick serve restaurant, but in construction, it's how do we program this thing that it doesn't take hundreds of thousands of dollars for a software engineer to come in and train these new behaviors. Anytime maybe somebody wants to train it to pick up garbage across the construction site, they're not going to bring a software developer in there to train that. Or it's cooking a new type of French fry or fish nibbler or whatever it is that might need a new behavior. Well, can we improve that behavior training time from 2 people 2 weeks down to less than an hour? That has real revenue savings in our approach.
Got it. Okay, so if we are each building companies that solve a really pressing, acute labor problem that's vexing society today, we're changing our world as best we can. The market is waving us on, saying, hurry up. Using a magic wand scenario, if you had one thing that unblocked the growth and the pace of what we're doing, what would that one magic wand yield you? For Miso, it would be software engineers. They're the heart of making all the hardware work together. I would wave the way out and say, give us more software engineers. What are your answers?
Yeah, I mean, I think that the biggest thing is as we want to get there faster, we need to raise more money faster to hire more software engineers to ultimately get more hours under our belt to improve the efficiency, the autonomy, and prove that it's safe. So it really comes down to time, money, engineers, building the product and getting it out there to the public.
Right.
I mean, cash is always king, right? The more money we have, the faster we can develop because the more bodies we can bring in to shorten our development cycles. But really just having like hardcore engineers that are really capable is always super helpful.
I would say certainly capital, but I also look at, in our product approach, I look at how do we solve automation in ways that people intend it to operate. It operates the way that people intend it to operate. And that really becomes a large data problem. So with the Ally arm, we're looking to connect our robotic arms. And this data set can feed our synthetic modeling of what are all the different scenarios, actions, tasks that we're going to perform so that ultimately at the very end of the day, when somebody is using the arm, it feels magical. It just works as though it's intended because we've looked across thousands of data sets on how people are trying to use this arm, and now we've tuned that to how you intend to use the arm.
Got it. So creating robotic companies requires a lot of capital, like any technology, but robots are also expensive to purchase. Can either one of you talk about how you're overcoming that, either a subscription service? So let's actually go do this. Could you each briefly describe your revenue model and how you're making robots affordable for your customers? John?
Yeah, so we started out, a traditional model of selling a mower and then a RaaS fee, robotics as a service at $1,000 a month. And, we did that, and from the time we started till now, with the supply chain issues and inflation, the price has gone up, and being electric, the batteries are very expensive, so it's quite a bit more expensive than a traditional lawnmower, a manually operated gas mower. So what we're doing is, as we get to scale, and we'll be able to lower that price to ultimately be able to sell the mower, with the RaaS, is we're doing a pay-as-you-mow model. So that way, my whole thing is, we've got to make it so easy for a landscape contractor to adopt our mower, and we've got to be able to mow as good or better and at a lower rate than it's costing them. So if we're charging them, say, $50 an acre, and they're normally paying $60 to do it in-house, why wouldn't they do it? And by doing that initially, it's going to prove out to them that they can get it done easier, redeploy their labor, and then as we go to scale and put more and more mowers out there, we'll be able to bring down our costs to lower that cost, and then go to the sales model or the lease model, or they can continue the pay-as-you-mow model. but we just want to make it as easy as possible to our customers. And that RAS, the $1,000 a month, is really important also to venture capital firms.
Right.
Yeah, we operate kind of on a dual model, and one is either sales with some sort of kind of nominal robotics as a service fee, just to make sure that the machines are running as they should and they're getting maintained and operating, with optimal uptime. But we also offer a leasing model for those people that don't have the significant capital. We're currently looking to sell these things for $50,000, which is, for those playing the home game, is about 1/5 what you'd pay for the minimum amount of a brick and mortar restaurant. But also for those people that don't have $50,000 in liquid cash, doing a lease plus ROS model is really going to be beneficial for getting people in, because again, back to Mike, your first point of, equity crowdfunding is the democratization of investment in the fastest growing asset class in the world, and we want to democratize access to robotics and people getting into the food service industry and people who want to be entrepreneurs in boba.
For Ally Robotics, we will certainly have direct sales with just unit outright purchase, but I look at more as kind of what John's talking about is this robotics as a service. I think about if I hire a person at my company, I don't hire them and forget them, right? So why would we do that to our tools that are helping us? And so I want to lean heavily into this robotics as a service model, because we're right there helping that whoever the end user is of our tech solve those problems, release new features. We've even created things where our arm has something that we call an endoskeleton design. So we have these skins that can be removed and replaced. And so now we can adapt these skins to different environments. Maybe it's a hard, stainless steel IP65 skin for clean food automation, or it's a soft compliance skin for a sport application. And so then there becomes this another vertical of accessories, and how can we create accessories to help people solve their problems that they're looking to automate.
Excellent. What's the biggest challenge you're working on solving like right now, like today? Like what's the biggest challenge at hand for each of you?
Biggest challenge for us is cooking boba. We're kind of under the understanding that the actual boba pearls themselves are one of the key quality indicators for a drink itself, and that's it's pretty easy to do in a traditional restaurant, but that stuff only lasts for 4 to 6 hours before it gets gross or it gets sticky. And this is something that we feel like we can really target, and is a huge opportunity not only within the machine itself, but for applications for existing shops, that if we can find a way, and something that we're actively tackling, of automating that process so that we can be cooking in real time, again, frees up somebody to bring them front of house to be better customer service, but also is going to provide a better and more consistent quality across the drink.
Let's finish up by looking way ahead, okay? So Miso, my team and I have looked back of house at restaurants, and we've identified 24 distinct opportunities for automation. Now, some of those are just computer vision opportunities, but we look back of house and we see 24 opportunities for robots. Now, we don't envision a humanless restaurant, at least nothing in the next 5 to 10 years. We think there's always a role for humans serving and helping other humans. But we look ahead, we see a significantly different future in the restaurant industry, one where very, very few tasks are actually done by humans. In 10 years, I think bringing goods in and out of a restaurant, trash in and out of a restaurant, things like that, there may be a handful of tasks that are still better done by humans, but a whole bunch of them are taken over by robots automation. So we see a radical transformation of restaurants. When each one of you look forward, how do you see your industry? And John, for you, it may be the question may be, when will we be driving down an average road and just seeing autonomous lawnmowers everywhere and it being commonplace? Like, what's your view ahead?
Yeah, so obviously we're starting with a lawnmower, but the way I look at it, we're building an autonomous vehicle with an attachment that's a rotary mower that can mow grass. We'll be able to switch that out to a real blade mower for fairways. We'll also be able to switch it out to put a drop spreader to fertilize that area that we've been mowing. Put on an aerator to aerate it, which needs it done in the spring and the fall. So there's all kinds of additional attachments we'll be able to do and other uses, solar farms, airstrips, the bulk mowers. So like you say, put an arm on it and do the edging. Edging is very, very labor intensive, very dangerous. It kicks up rocks. I don't know how many windows and cars we dinged with rocks. And just anywhere you walk, or at least anywhere I walk now, I'm like, that can be done with a robot. That can be done with a robot. Love to go skiing. You look at the groomers at the end of the grooming machines. That should all be roboticized. Right. The Zambonis. There's so much use that can be used that it's really endless.
Yeah.
Yeah, we're really looking at building a platform here. So, when we think about our current pod of this kind of like shrunk down restaurant or a next generation vending machine, what we're ultimately doing is automating certain tasks. And we're focusing on boba now because it's a delicious drink and think there's a huge opportunity there. But really, there's no reason that can't be translated to any other drink construction. As well as the stuff that we're developing in the machine itself could then be ported to existing shops, and we can start backfilling for their support. And so we're helping to automate their processes in the shop themselves to be able to make sure every drink is consistent, every drink is delicious, whether it ends up being a boba shop or a smoothie shop, that we're able to leverage this technology that we put into a box and serve that a la carte into a larger customer base.
I think about the future of robotics, it's really about what's the success criteria, and it's things like, are people doing dull, dirty, dangerous type of tasks, and also things where it's the everyday person can come in and use these robotics in useful ways for whatever they're trying to solve. I have one customer that he's saying, hey, I have a machine tending scenario, and unlike most machine shops, I'm not doing the exact same part in my CNC machine every day. I might run 3 parts, but my machine's running 100% of the time. So he's expressed significant interest on, if I can just visually show this arm how to handle machine tending, significant value. And it's opening up scenarios like that. Like another customer they do carbon fiber layup, and as a part of the final stage of that layup, they apply a clear coat for the UV protection. And they are not going to have software engineers come in there and program these paths. But if they could just show the robot that motion, applying this clear coat now, it allows them from a labor shortage challenge. It's now, that stage is now automated, and they could focus on getting the weave geometry correct. And so it's helping this company solve their labor gap and also increase their throughput and their quality. I think that's success.
Excellent. Well, gentlemen, you're each driving some super exciting change and innovation, not only in your industries, but in society as a whole. So thank you for joining me today in this panel, and thank you for innovating, and Godspeed to all of you.